Hello, we are discussing thin film solar cell technology. Welcome to D Creations Resources. We have already defined what exactly is a thin film, and now let us talk about the advantages that are offered by thin film technologies. First advantage is low material consumption. Now, since the fabrication of solar cell is based on thin films, and we have already seen that the thickness is at the max few micrometers. It starts from few nanometers and it could be at the max few micrometers. So the amount of material that is consumed per unit solar cell of given area is way lower. It's very lower, significantly lower than the wafer based solar cell technology, where the thickness is in terms of 200 to 300 micrometer. So here basically less amount of material is going to be consumed, and this lower material consumption leads to lower production cost, and hence the cost of PV modules is very low. The second advantage is shorter energy payback period. Now what exactly is energy payback period of a solar cell? It's basically the time of cell operation in the field during which it will generate the amount of energy equivalent to the energy required for its production. So it's as if paying back that energy. So certain energy will be consumed when for its production, and that energy, when it is given back, the duration in which that energy is given back is basically the payback period. Now, for thin film technology, this payback period is less than 1 year, many a times, while the payback period for silicon wafer based technology is 2 to 3 years. The third advantage is monolithic integration. Now we know that when you want to use solar energy, we don't use a single solar cell. There are panels, there are modules. So monolithic integration refers to a process in which the solar cells are connected in series during the fabrication to make a module. Now thin film technologies, if you see, they offer the possibilities of monolithic integration. Whereas if you compare it with wafer based technology, then it's going to be a very labor intensive task, and it will lead to increase in the module cost. So thin films are better suited when it comes to monolithic integration. Now the fourth advantage is large area modules. So the size of a wafer based solar cell will depend on the wafer size, which basically will depend on the production capability of silicon ingots and wafers. Now the size of wafers is usually say 150 millimeter by 150 millimeter, or basically 225 centimeter square. Now that's not the case for thin films. In case of thin films, the area depends on the size of the equipment used for deposition. And in fact, nowadays, large area thin film modules, so as large as even 57,000 centimeters square, are being fabricated. And large area fabrication capability also gives cost advantage. So thin film technologies allow the fabrication of cells and modules of any arbitrary size within the limit of fabrication tool. The next advantage is tunable material properties. The optical and electrical properties of thin films depend on the structure and the composition of the films. For most of the thin film technologies, both these parameters can be controlled at the time of deposition by controlling the deposition parameters. So if you control these parameters, you will be able to tune the optical and electrical properties, and this flexibility is useful in realizing the multi-junction solar cells, where basically you need to harness large portion of solar spectrum. Now this is not possible with bulk wafer based silicon solar cells. So again, thin films have an advantage here. Another advantage, maybe the sixth advantage, is low temperature processes. So most of the processes that are used for the fabrication of thin film solar cell can be done at temperatures less than 500 degrees Celsius. So we will say that these are lower temperatures, or they can even be done at temperatures as low as 200 degrees Celsius. Now these temperatures are lower as compared to temperatures required for wafer based silicon cell manufacturing, where it's around 800 degrees Celsius to 1000 degrees Celsius. So we can say that the overall thermal budget of thin film technologies is low, and the low temperature processes allow the use of cheap substrates like glass, plastic, stainless steel foils, etc. With this, these could not have been used had the temperatures been very high, for example in case of wafer based technology. Now another advantage, or maybe if we are counting the advantages, this could be seventh advantage, is transparent modules can be made. So thin film material can be deposited on the glass substrate and the thickness of the films can be controlled. The film thickness less than the optimum required thickness to absorb full spectrum will be transparent in nature. Now such transparent modules can be used in buildings, providing both light and electricity during the daytime. So there are several advantages, but does that mean that there are no disadvantages? Certainly not. There are some disadvantages as well, and one major disadvantage is the low solar cell efficiencies. As we know, efficiency is a key parameter when it comes to solar cells, and here since the efficiency is low, you will need to have large area thin film PV modules if you want to generate a given amount of power. So if you compare it to wafer based technology, here you will need large area. Also the low cell efficiency results, so we know basically the reason, if you want to say the cause of low cell efficiency, it's the structural deviation of thin films, or there could be defects, for example. And if you compare now this to the bulk wafers that are there, definitely the defects will be more in case of thin films. And since there are defects, this gives poor electrical properties of the film. So the carrier combination rates and diffusion lengths, they are going to depend on that. So basically the structure defects can affect the stability of the material. So these are the advantages and disadvantages of thin film technology.